Here is your free response question for today. So from 0 to 6 seconds, a screensaver on the computer screen shows two circles that start as dots and expand outward. At the instant that the first circle has a radius of 9, the radius is increasing at a rate of 1.5 or 3/2 centimeters per second. So we'll annotate it a bit. This word rate is important. Find the rate at which the area of the circle is changing at that instant. Indicate the units of measurement. So to start with, this is what is called a related rate question. So we need a formula to start with. So what is the formula going to be about? Well, it's about a circle and area. There it is. So the area of a circle is pi r squared. So it's a good place to start. Then we're going to take the derivative of this with respect to time. So the derivative of a is 1, but we need a prime, or dA by dt. The derivative of pi r squared, the power rule, 2 times pi in front, subtract 1 from the exponent, and it needs a hook, dr by dt, because we're taking the derivative with respect to time. Then we need to do a substitution. So first of all, find the rate at which the area, so that's dA by dt, that's what I'm looking for. Nothing to plug in there. The radius, do I know what the radius is? Well, it says the radius is 9. Do I know what the rate of the radius is increasing or decreasing by? What's the rate of the radius? Well, the rate of the radius is 3/2. And then the last thing I need to include is the units of measure. So what unit is this in? It's in centimeters and seconds. And you just answered it. So when the radius is 9 centimeters, the area of the circle is increasing at a rate of, and then you don't even have to simplify this, centimeters per second. Well, there it is. Part B. The radius of the first circle is modeled by this equation from 0 to 6, where t is measured in centimeters and t in seconds, or WT is in centimeters. At what time is the radius of the circle increasing at a rate of 3 centimeters per second? All right, so let's start with what we're given. So the radius is multiplied by this. So this, think of this as the radius. So if I want to find the radius at 1 second, you just plug in 1 for t and it will give you the radius. Then it says, I need to find the rate. It says at what time is the radius increasing at a rate? So if I know this is the radius, the rate then would be the derivative. So the derivative of 12 is 0. The derivative of the second part, you need to go and rewrite what you see, negative 12 e to the negative 0.5t, but it has a cute little hook. The derivative of negative 0.5t, which is negative 0.5. You don't have to, but it might be helpful. Negative 12 and negative 0.5 together, that makes positive 6. Then it says, at what time, so I'm looking for t, is the rate, increase rate of 3 centimeters per second. So I'm going to plug in 3 for the derivative and make it equal to 6e to the negative 0.5t. And then I'm just going to solve for t. So to solve for t here, you would divide by 6. 3 divided by 6 is a half. You would write it as a logarithm. So to do that, you write down the exponent. And the logarithm basically is ln, and what goes inside is 1/2. And then the last step would just be to divide. So it's ln 1/2 divided by negative 0.5, and that answer is in seconds. And that's a great answer. You don't have to change that answer at all. So that a good sentence would be, the radius is increasing at a rate of 3 centimeters per second at what time? At time t equals ln 1/2 negative 0.5 seconds. Done. All right, part C. Here's the last part of this free response question. It says, a model for the radius of the second circle is given by the function from 0 to 6, where f at t is measured in centimeters and t is measured in seconds. The rate of change of the radius of the second circle is given by this derivative. So you're given the rate for the radius. Based on this model, by how many centimeters does the radius of the second circle increase from 0 to 3? So if I want to know the increase and you're given the rate, that's an integration question. So the idea of how much did it increase and you're given the rate, we integrate to know how much that increase is. And obviously we're going to integrate from 0 to 3, and it gives us the function. So that's what we're going to do. So the rate would be t squared minus 4t plus 4. To integrate this, just the anti-power rule, so that would be t cubed divided by 3. That would be 4t squared divided by 2. And that's 4t. And we're going from 0 to 3. Plug in 3. And then when you plug in 0, don't assume it, but you should know that, have enough number sense that when you plug in 0, it is going to be 0. And that's it. This is the answer you're looking for. So let's read the question again. Based on this model, how many centimeters does the radius of the second circle increase? So we're going to write down from time t equals 0 to t equals 3 seconds. Here we go. The radius of the second circle increased by hello. Okay, sounds good. So the radius of the second circle increased by, and you can just write all of this down, not simplify it, and then write down centimeters at the end. And that's it. All right, good job doing a free response question with me today. Mr. G Math, over now.